student. Okay, now we're live. Now we can start doing some work. So last time we had a little philosophy discussion, always a fun part, and then also like a lot of logistics about how the course is running and those kind of things. So I wanted you to take a second, check in with a neighbor, like how do you feel like the course is gonna go? Are there questions? Like, do we need to revise like either syllabus or how things are gonna happen? Yeah. For IPython, you shouldn't need to download IPython, but I can always help you troubleshoot. Like if you want to run things locally, then I can help you get running. I like Anaconda or at least like Miniconda for running Python stuff. But I'm working with Purdue. They have a Jupyter server that can provide access for us. So we should be able to just click a link and go and run code there. You know, trying to get like homework 0 done. Yeah, so for homework 0, like this interacting with, right now this Jupyter Hub is not working. They updated my server from Red Hat, I think it was like Red Hat 7, now it's like Red Hat 9, so skip a few, and I haven't been able to get it back up and running. So I'm working NanoHub at Purdue is like always an up-to-date Jupyter. Anyway, this is tomorrow problems. Yeah. Yeah, we can move it. What is it now? It's Monday. Oh, Monday? No, Friday, right? It says Friday, so we got time. What's on Monday? Well, I know Labor Day is Monday, but thank you. Yeah. Is this on Monday? Is that right? No, that's Friday. I don't think we have due dates. All right. So anyway, that's a good question about like what is upcoming in the. I don't know if you've used this in the past, but in Husky CT there is like a calendar and then a due date kind of checklist of what's coming up. And it looks like nothing's due on Monday. I was trying to have nothing due on Monday, so when you said it was due then, I'm like, that doesn't sound like me. Not that I don't do that, it's not that I mean to do that. Yeah. So it's not due Monday. And we have next week that we can get everybody signed up, running Jupyter and getting coding. But yeah, thanks. So yeah, check in with a neighbor, especially for like things like that of like, hey, can you get Jupyter running? Or what's with this guy? Why is Jupyter happening? Why is Python happening in this class? Yeah, and I'll walk around and see what questions are coming up. That's a good segue to planning things. It gets really complicated, so what I like to do is just choose one path. Yeah, and this is like way beyond where we In this one? Oh, sorry, over here? Here. Yeah. Yeah. In this Python anywhere, you mean? Because this one lets you like run Python code right there. But it lets you run little codes right there. But anyway, yeah. We won't have to like install it unless you want to. I mean, I guess sorry, the second question, there's like, what is new second law? That one's pretty, like, close, like, converted, like, everybody knows. So besides materials, so usually dividing what happens is when you have like some courses, some materials how does that structure form? Something like law. But it's transferred to force, and sometimes accelerating momentum, changing reference rates. So that's like the dividing, the rough dividing line between the two. Yeah. But they are, it's all connected. You can't do that at all. Free body diagram. Yeah, we have 5 but that's good. Initially, it's all when we're like done with all of that. Remember in tutorial 3.2. Definitely videos. Because I know I've submitted videos before. Yeah, so when I said like insert a file, it does let me. I think it'll let you put any attachment in there. I'm pretty sure, but I could be wrong. All right, so some of the questions, and if more questions are coming up, like especially as you're talking to other people, then we can keep discussing those. But some of the things that came up were like for homework 0, there's a Jupyter. It's a website. Trying to get back to homework 0. But it's a website, and the title is Interacting with Python, and it's a Jupyter notebook. Right now, we don't have a Jupyter server to actually run this code and edit it, make changes, and then save that stuff. So by next week, we'll have something up and running, so we don't have to worry about this, at least today, like right now. If you're trying to like work ahead and you're like, I can't wait for some jabroni to get me into Jupyter, you can download it yourself and you can run all this on your own computer, not be in the cloud. But if you don't mind waiting, we can just wait a couple of days as I get the NanoHub server up and running. Then the other things that came up were, all right, yeah, the question of like, how do I get an audio or a video submission into that quiz 0? For the most part, if you're like clicking this like add attachment, it lets me add almost any attachment in there. So like whether it's an audio file or a video file, it seems to work. I haven't had problems yet, but oh, the video. All right, so I'm overhearing. So like in quiz 0, the goal is get a PDF of like your solution. So one free body diagram of Spider-Man. Question number 2 is write down Newton's second law. And so far, I think everybody knew Newton's second law since it's been hammered into you for the last 2 to 3 years anyway. And that's where you're also adding like 10 to 30 seconds. So it's not like a long video blog on what this quiz means to you and society. It's just like a quick, this makes sense, I'm good to go, or like, what's with the free body diagrams? I've never done this in my life. Like something on that scale. And same thing for the other quizzes. So the other part that came up from this was sort of like, what is the structure of this class? Like how there's readings, there's homeworks, like it's a flipped class. So if I'm supposed to be doing readings, when do I need to get them done by? And the general pace of the course is like, we have 15 weeks. We're here in halfway through week 1, roughly 3 weeks per module. And module number 5, this last one, is going to be an independent research project. It's not like a big term paper. It's 2 weeks to spend like building a model and talking about like what's important about that. And we'll build that up slowly throughout the semester. Yeah.
So are there exams?
No in-class exam, no final, no midterm. Yeah.
So it's only the homeworks and the quizzes? And then
Homework, quiz, and projects. Yep.
Okay.
Yeah, so each module 5 is different, but here we'll do a tour. Module 1, if we replace 1 with 2, 3, 4, it's the same thing. So module 1 has a homework, it has a quiz, it has a project. And project 1 is going to be planning what you're going to do in module 5. And again, we'll like work on that together in class. And then module 2 will be the same kind of structure where we have a homework, a quiz, and a project. And project number 2 will be building like a 4-bar linkage mechanism. So like 3 moving parts that are mounted to 2 stationary locations, and they move like in a circle to kind of oscillate and drive some kind of mechanism. So that'll be like what we're building, the kinematics that we're building towards in module 2. 4. I saw you like head map. Yeah. Sorry. Is it difficult? Here, let's do of a swing. Actually, let's see. Sometimes I break this. Oh, I broke it. Because sometimes FFmpeg is not available when I do the build. But anyway, like if we think of link 1 and link 2 on either side, as they rotate, link 1 moves around in a circle, and link 2 is trying to follow it, connected by link number from that connector link. As it does that, we can actually, in this case, it carves out like a little following the center. Makes this little heart shape, or it's upside down, so it kind of looks like a butt. But as you follow that point around, if you flip it upside down, it looks like a nice heart. But now we're getting mooned. Yeah, and then module 3, again, like reading, homework, quiz, project. And project 2 is kinematics, like looking at what are constraints, how do you model motion when it's constrained. Project number 3 is looking at, we'll model pendulum swinging, so looking at like what are the governing equations and how can we compare that to like an actual experimental measurement of it. And then module 4 is looking at like yo-yo de-spinning, nice like space project where you have something in space, it's like spinning out of control, you can release this mechanical mechanism. And just by unraveling these yo-yos and cutting them loose, they go off into space and you stop spinning. So that'll be like module 4. And these projects are meant to give you kind of like an idea of what you can do with dynamics. It's not like these are the only things that you should know for this course, for this subject, but I think they're interesting and it's kind of fun to go through the analysis too. So when we're looking at like, if you're trying to plan out when does the reading need to get done, roughly like when homework 1 is due on the 12th. So we got like 2 weeks, another 2 weeks until homework 1 gets turned in. that's when you can kind of space out those readings or videos until homework 1 is submitted, and then we can build quiz number 1 together, submit quiz 1, then work on project. And same thing for 2, 3, 4. And I think those were the what other questions did I miss? Did anything else come up while you were talking? Yes? Quiet. It's too hot in here. It's like falling asleep. Quiz 0 we're covering, homework 0. We'll get to that. 9/3. Oh, when does this one due? Tuesday. Okay, good. Not. All right, no one asked about this, but one of the ways you can ask questions for the class, like especially stuff like how do I do this, or I don't, like, you did something in class, it doesn't make sense, or where is this equation coming from? Those are all kind of great questions that would help everybody learn. You can also ask like logistical questions on this discussion forum, like I don't know, what are the best video formats for submitting like quiz responses or something. But I won't track like how many discussion posts or anything you have in the class. This is purely meant to be like a tool to help us communicate in some asynchronous way. But I do want you to at least have access to it. So I want you to make one discussion post and show me that you have a link to it. So that's the first step there. And just a couple of questions of like, what kind of job would ask for skills from this class, and what's one thing you miss about summer, and then the nice, this was the selling point for me at least, was like, oh, I can use LaTeX in discussion forums, sweet. But now you can have like formulas written in this discussion forum. So if I'm gonna respond to this, I'll like scroll down. So I need to find a job post. Job post coming soon. Number 2, something that I miss about summer. This summer we spent a lot of time like sailing, which I hadn't done since I was like a teenager, but it was really fun to like get back on the water. My 9-year-old son got really into it, so that I guess that's the thing that I miss. And then number 3, writing an equation. I'll write my favorite equation. Sigma ij equals c ijkl epsilon, if I can spell, kl. So I'm writing out Hooke's law in a full form where I have like the 6 components of stress as ij components, all related through ijkl, like stiffness components, compared to epsilon, like strain, in a KL form. We don't have to deal with that in this class because everything's rigid body, but it's an example of like using LaTeX equations. Yeah.
Are we supposed to like look up the like equation and run that like as
How to learn LaTeX?
Yeah.
Yeah. So if you want to, yeah, do I have a link to it? No link. Sorry. Hey, ChatGPT. I need Newton's second law in LaTeX. And this would work. But so one way, there's lots of like documentation on like learning LaTeX, but documentation is slowly getting forgotten about, and everything is like, here's our AI driven documentation, and LaTeX a great example of that. Like, it can be very hard to learn at first, but there are a lot of great resources, and those have all been collated and smashed into ChatGPT. So this is one way that we could do that, saying like, I need you to turn this into a LaTeX equation. I don't exactly know how to do it. So if I wanted to grab this, I don't need the begin and end like stuff, but I could grab that and put it into if I add these $signs, now it's showing me like vector F equals M vector A. Pretty slick, low impact. A little bit, you're giving up a little bit because you are helping, you're like giving information to ChatGPT in that case, but it did help you accomplish a task. Maybe it evens out. I don't know how many watts of, how many like kilowatt hours I just used by asking for that, but I don't know. It's so easy. It was just so easy to do though. So I'm a big fan of like AI tools in general. For stuff like this, I wouldn't really ask for attribution of like, I asked ChatGPT for this code. But if it's something else, like if I'm asking you a question about dynamics and you're not sure what I'm asking and you're using ChatGPT to answer that, then definitely like attribute like, hey, I got these parts of this answer from ChatGPT. If it is something that you want to use and that's part of your normal kind of workflow. Yeah. But I like the arrows on top of that. Usually I use like bold, like math BF, but I like that vec. That's a nice way of doing it.
Are the $signs supposed to take like the beginning to end? Or that's what ChatGPT is writing?
Oh, instead of beginning end? Yeah, so like in this one, it's assuming that you're writing a whole LaTeX document, and in the document you can use $signs, or you can say begin and end that equation. But this is like I could specify, it's like instead of saying Newton's law in LaTeX, I would also as an inline equation. So an inline equation should use, oh my god, it should use $signs, but it gave me that like slash parentheses. Why? And it messed up. I don't know if that one works. Yeah, it doesn't work. You got to use $signs for our discussion. $signs work. but beginning and end, it's not like a full LaTeX thing. All right, so I'll add my comment. I still need to add like a job post. Oh, nice. Got more replies. Once you have that submission in there, you can copy the link, click those 3 dots, and that's where I can come in and say, this is I'll start my attempt number 1 and paste it right in here. And then once I've submitted that, now I have like a link to that discussion post. Cool. Do you want to try that now? You should be able to do it like on mobile or iPad, where you could try doing discussion posts. Then there's just like less stuff to go home and remember. We just like get things knocked out as they come up. Any questions on that? But we don't have lessons. Yeah, that makes it harder to follow along. But this course is not there. Okay. Okay. Yeah. And are you registered for the course now? Still. Okay. So you're still figuring it out. Okay. Most of the time, once you're registered, you'll go right file that section. But if not, then we'll have you an idea. Like if it doesn't, if you get registered but you still don't see it, then send your ID. Those should be 3 letters. And then I can add you. Yeah. You should be able to just add some. That's fine. Yeah. Yeah. There should be every time there should be right, so thinking about like what are jobs that are actually connected to dynamics, robotics is like I'd say 70 to 90% of robotics is just thinking about just the motion, like how is motion defined, identifying degrees of freedom, what is the geometry of that motion, if I have a path that I want to follow, what do my motors need to do? So like anything, whether it's like automation, like using robots, there are robots called like fully automated, like robotic automation of stuff. There's also cobots. Have you heard that term before? A cobot? A cobot is like a human and robot cooperating together. So it also has safety features that it's not going to like whack the human or something. So cobots are usually like a human is doing one thing and hands it to a robot, it does something, then it hands it back. But some kind of, rather than like a fully automated assembly line, cobots are like more niche manufacturing where you need more human interaction as you're checking it. But iRobot, they're looking for like a robotic scientist. Let's look at what they need. Solve problems, innovative solutions. And here we go. Computational geometry, optimization, and probabilistic robotics. So we're not going to deal with like probabilistic stuff, but definitely computational geometry. That's another way of saying like kinematics, like thinking about geometry of motion. That's what we're doing here in this class. So like if I was applying this job, I would say in my Applied Mechanics 2 class, I focused heavily on computational geometry to do something like model pendulums, look at 4-bar linkages, something like that. Welding, let's see who else pops up. Who else is looking for robots? Or come in here, I look up kinematic. Who's looking for? Not so many people. Automation designer, that one's out in Michigan. Maintenance manager, controls engineer over in Rochester. So in this case, it's looking for someone like designing or assisting electrical, pneumatic, hydraulic control systems, like all that, the fundamental equations and like underlying stuff is going to be based on like how much force do we need, how much power do we need, how much stress is going to be in this system, and all of that is like questions that dynamics is the first building block towards. Like what's the free body diagram, how are things being loaded, how much power, like if we're accelerating something, how much power do we need to do that? But just thinking about where's this all taking you? Like what do you want to do with this rich engineering degree and training that you're going through right now? Usually when you do submit stuff, Husky CT now gives you like data, like a file that proves that you submitted it. I don't need it. I'll trust you. If you say you submitted it, then I'll trust that you submitted it. And if an error happened, it happens. Stuff like that. It's technology. Sometimes things get lost. So if you like keeping track of these receipts, then you're welcome to. But I'm not gonna fight. I'm not gonna fight you. Like I'm not going to ask for this receipt ever if you say. It's like, oh, the submission should be there. Can I still get credit? It's like, you still get credit. It's fine. You don't. It's okay. things happen. So if you want it, download it. I would just exit out. Started. We got like 2 minutes left. Okay. So I guess talking about like submissions and deadlines. Every assignment does have like a deadline, so we're all laid out until the end of the semester. I don't need like excuses like or reasons to turn something in late. Like if you need extra time, like you don't need like an excuse to turn something in late, but give me like a new, like, let us know that it's gonna be late. And one good way to do that is just like in the assignment submission. So here, like right where, let's say the discussion post of like, you could in this discussion link just say like, hey, I need 2 more days to complete this assignment. So first thing that I need to know is like when, if you're going to turn it in late, it's totally fine, but let me know how late is it. If it's a couple of days, it's no problem. If it's gonna be like 7 weeks, then I might worry that like, okay, some of this stuff is building on previous knowledge, so we need to have like some schedule. So as long as you have like some idea of how much time you need, totally fine. The other part that I want to know is if you need help, how are you getting help? So like, I need help with GitHub account. I emailed Professor Cooper. Totally fine. Or even like a friend is going to help me over the weekend. Like anything, but those are the 2 things that I need if the assignment's late. Like, how much more time and what help do you need? How are you getting it? Sound good? All right, by next time we should be able to fire up Jupyter and then start getting acquainted with Python.